Have you ever wondered how we get a single number for something like inflation? I mean, you've got millions of prices for everything from milk to Teslas, all changing constantly. How do you boil all of that down? Well, it's not magic, it's math. And today, we're going on a quest to find the perfect formula that makes sense of it all. Let's get into it.
So here's our game plan. First, we'll look at the basic problem we're trying to solve. Then, we'll check out two early formulas that tried, and kind of failed, to get it right. After that, we'll meet the ideal contender that showed up to save the day, and we'll put it through its paces. Finally, we'll see how this math actually affects your wallet and wrap up with a quick reality check.
All right, so first things first. We've got to understand the core challenge here. The prices for, well, everything, are always bouncing around. To get a handle on the big picture, like the real cost of living, we need some way to wrangle all that chaos into one single meaningful number.
I mean, really think about it for a second. If the price of gas shoots up, but the price of, say, avocados goes down, what does that actually mean for your budget? How do you decide which price change matters more? That is the puzzle we're here to solve.
And the tool that economists came up with for this is called an index number. It's really just a clever way to take a whole basket of things that are changing, in this case prices, and distill them all down to a single figure that we can actually use to compare things over time.
Okay, so our quest officially begins. Back in the 19th century, two main formulas popped up to try and calculate these price indexes. And, they were both pretty smart, but as we're about to see, each one had a major flaw. So, let's meet our first two contenders, Laspeyres and Paasche.
The big difference between these two really comes down to their point of view. Laspeyres' method basically asks, what would it cost to buy our old basket of goods at today's prices? Paasche's method, on the other hand, asks, how does the cost of what we're buying right now compare to what it would have cost in the past? So one is kind of stuck in the past, and the other is totally focused on the present.
And right there, that's the problem. Laspeyres' method ignores the fact that when prices for something go up, people tend to buy less of it and switch to cheaper stuff. Because it misses that, it tends to overestimate inflation. That's what we call an upward bias. Paasche's method has the opposite problem. It often underestimates inflation, giving it a downward bias. So you've got two formulas, the exact same data, and you get two different biased answers. Not exactly ideal, right?
Let's make this way more concrete. Take a look at this super simple data for three items. We've got their prices and how much was sold in our base year, 2010, and then again in a later year, 2015. We're going to run these exact same numbers through both formulas and see what they spit out.
So first up, using Laspeyres' method, the one based on the old 2010 shopping habits, we get a price index of 239.58. Whoa, that suggests the cost of that original shopping cart has more than doubled. But remember, this is the one with the upward bias, so this number is probably a bit too high.
Okay, now let's run the exact same data through Paasche's formula, this time using the 2015 quantities. And we get 240.57, a different answer. And this one, with its downward bias, is probably a little too low. So, which one is right? The real answer's got to be somewhere in the middle. And this is where our hero, the economist Irving Fisher, swoops in. He saw these two formulas with their opposing biases, and he came up with a solution that was just beautifully simple and elegant. Fisher's big idea was, why pick a side? Let's just combine them. He used a special kind of average called a geometric mean. Now, don't get hung up on the math. All you need to know is that it's the perfect tool for averaging out rates of change. By taking the geometric mean of the other two indexes, that upward bias from Laspeyres and that downward bias from Paasche's, well, they pretty much cancel each other out. It's genius.
And would you look at that? When we calculate Fisher's index with our data, we get 240.07. It lands perfectly between the Laspeyres and Paasche results. It's like the Goldilocks number. Not too high, not too low, but just right. It's the balanced number we've been searching for.
So what makes this thing ideal? Well, for one, it uses that geometric mean, which is really considered the best average for this kind of work. It also cleverly uses information from both the past and the present. It balances out those annoying biases we saw earlier, and this is the big one we're about to see, it actually passes two really important tests of logical consistency.
See, a good formula can't just feel right. It has to be logically sound. It has to hold up under pressure. And to prove it, Fisher came up with two simple but super powerful tests. This is where his method really pulls away from the pack.
So here are the two big tests. First, you've got the time reversal test.
It's simple, really. If prices double going from year 1 to year 2, they should be cut in half going from year 2 back to year 1. The math should work both ways. The second is the factor reversal test. This one says that your price change multiplied by your quantity change should equal the total change in spending. I mean, that's just common sense, right?
So here's how they did on the first test. L'Esperes and Pachet's, they both fail. The answer you get actually depends on which year you pick as your starting point, which just doesn't make any logical sense. But Fisher's method? It passes with flying colors. The result is consistent no matter which way you look at time. That's a clear pass.
And for the second test, yep, it's the same story. L'Esperes and Pachet's just don't properly account for how price, quantity, and total value all fit together. Only Fisher's Ideal Index gets it exactly right, perfectly balancing all the factors. It is the only one of the three that passes both of these basic, fundamental tests for a good index.
Okay, so that's all the theory. It's kind of cool, right? But why should you actually care about any of this? Well, because these numbers, this math, it has a direct, real-world impact on your money and your purchasing power.
And that brings us to this really important idea called deflating. It's basically how we use a price index to strip away the effects of inflation so we can see what's really happening to the value of our money.
Just imagine this. You had a fantastic year at work. Your boss loves you, and you get a 3% raise. You feel pretty good about that, right? Your paycheck is bigger, life is good.
But then, you turn on the news, and the official price index, which is probably built using sophisticated methods like Fisher's, shows that the price of everything, on average, went up by 5% that same year.
So what happened to your real wages? Well, we take your money wage and we deflate it using that price index. So even though your paycheck went up by 3%, the cost of living went up by 5%. In reality, your actual purchasing power, your ability to go out and buy stuff, went down by 2%. That is the power of an index number. It tells you what's really going on.
Now, before we wrap this up, we need a quick reality check. Because even though Fisher's index is called ideal, no statistical tool is ever going to be absolutely 100% perfect. It's really important to know their limits.
For starters, these indexes are built using samples of products, not every single item sold in an entire country, so there's always a little room for error. The choice of what year you call the base year can also nudge the result one way or another. And maybe most importantly, an index built for one thing, like measuring consumer prices, can give you really misleading answers if you try to use it for something else. They're powerful, for sure, but they're not perfect.
So, I'll leave you with this question. We hear about the Consumer Price Index, the CPI, all the time on the news. It's our main yardstick for inflation. But now that you've seen what goes on under the hood, the biases, the logic, the elegant math, what do you think the CPI is really telling us about the economy? And more importantly, what might it be missing? That's definitely something we're thinking about.